Okay, now we have an idea of what the PMF is. Essentially, this here is the definition for a random variable x. The PMF value at k is equal to the probability that random variable x takes the value k. This is the definition. Now, when we look at the properties, the first one we will recognize is that since the PMF is defined in terms of a probability, it has to satisfy Kolmogorov's axioms, and therefore it has to be non-negative. That is the first property. Any value of the PMF, it has to be non-negative. And secondly, and this is obviously the most useful property, for any event A regarding or involving our random variable x, we can write the probability of this event by adding up the PMF values that correspond to the values that are included in the event A. Now, this is a convoluted way of saying to compute any probability, just add up the PMF values that the event includes. Let's see this on a simple example. Assume that a random variable x has this PMF. Okay, so when we look at the PMF, we obviously see the values or the outcomes that the random variable x can take. Now, the underlying random experiment does not really play a role here. We don't really care about what the random experiment is because now it's translated into a random variable. Now, we can define some events on this random variable and then how to interpret the values that those events take, the probability values, that entirely depends on the definition of the random variable. But at this point, we do not care about what the probabilities mean, but rather how to compute the probabilities. Now here, the values that the random variable take are 1, 2, 4, 6.5, and 7. Okay, so let's see how to compute the probability of this event. X is less than or equal to 3. Now you see our events, as I said, are defined in terms of random variables now, because and notationally it's much easier and it's easier to work with because I can write x less than or equal to 3 to mean the outcomes of 1 and 2. So this means x is in the set 1 or 2 because those are the outcomes that are possible and also satisfy this event here. And to compute this probability, what I'm going to do is just add the probability, the PMF values at these values, 1 and 2. Okay, so this PMF value at 1 is 2 over 3, sorry, 2 over 8. And the PMF value at 2 is 1 over 8. And therefore, this probability is 3 over 8. Very similarly, we can compute the probability of the event that random variable x is between 2 and 4 inclusive. Now, with especially discrete random variables, you should always be careful about the inequalities, whether they are strict inequalities or inequalities with equality. Now, here you see 2 is included in the event, as is 4. Okay, so 2 less than or equal to x less than or equal to 4. That gives me these two outcomes, 2 and 4, since they are included. Therefore, this is going to be equivalent to this event, and I can find the probability of that event by adding the values, the PMF values of x at 2 and at 4. And this is 1 over 8. This is at 4, I have 3 over 8. So this probability is 4 over 8. Now, if I write this not in this way, let me just ask another question. Instead of this event, let's say I want to find the probability of the event 2 less than x less than 4. Now, in this case, you see the inequality type is important since here 2 is excluded and 4 is also excluded. And this is equal to the probability of x being in the set 2 to 4. This open interval because 2 and 4 are excluded. But when you look at this here, between 2 and 4, excluding 2 and 4, I do not have any outcomes. Therefore, this probability will be 0. Or for instance, if you include 2, but exclude 4, 2 less than or equal to x less than 4, in this case, this is going to be equal to just the PMF value at 2, which is 1/8. Or if you want 2 less than x less than or equal to 4, this will be equal to the PMF value at 4, which is equal to 3/8. Okay, so to emphasize the message here again, you have to be careful about what values are included and what values are excluded. So the type of the inequalities are very important. Okay, for instance, look at this probability that x is greater than 4. Now you see 4 is excluded. Therefore, I'm just going to include these two and add their PMF values. 1/16 plus 3/16. Another example. Now, you see this is defined, this event is defined as a function of random variable x. X minus 4 absolute value greater than 1. So now we will have to determine which values of x or which outcomes satisfy this event. And those are 1, 2, 6.5, and 7. Because 4 does not satisfy this event. Therefore, it will be out. And if you want to find the probability of this event, you will have to add up these PMF values. Okay, so a final example here. X minus 4 absolute value equal to 3. Now, the values or the outcomes that random variable x can take and that satisfy this event are 1 and 7. Okay, therefore, to find this probability, add the values of those PMF values. PMF of x at 1 is 2/8. At 7, it is 3/60. Okay. Now, one final observation is that when you add all the values of the PMF function, you see this one, this one, this one, this one, this one. So you add the PMF values over all possible k values on the real line. This will correspond to the probability of the sample space itself. Therefore, it should be equal to 1. Okay, so let's look at this. This is 2/8, 1/8 makes 3/8. Together with this 3/8, it makes 6/8. And these two make up 2/8. Altogether, you have 1. So this is a legitimate PMF. Okay, for instance, if I tell you, okay, this is a graph of a PMF, and when you look at the graph, if the values do not add up to 1, then you should say, okay, this cannot be a PMF function. Okay, so any PMF function, this first property, any value should be non-negative, and this one, all the values, when you add them up, it should add up to 1.